Hello guys, today we are going to look at real world applications, case studies, and we have three case studies. One will be about economic data analytics, two will be about healthcare data analytics, and the third one will be about survey data analytics. So we will move direct to STATA and start right away. And this is the last module of STATA, which will, after going through all the modules, you need to be at advanced level of STATA data analytics. And we are going to perform analysis on pre-generated datasets with descriptive statistics, visualization, as well as hypothesis testing. We are starting right away with case study number one. And case study number one deals with economic data. And we need first of all to load this data. Data is called economic underscore data.xls. And for each and every dataset, we are having a unique research question. And remember, in any survey, we must have at least, maybe you can say, 3 or more research questions. But now in this case, it's just like a sample. Now we will be using a single research question. And in this case, this research question is GDP per capita significantly associated with unemployment rate. Is GDP per capita significantly associated with unemployment rate. So before we do anything, let us check and see our data. Region, we have GDP per capita, and you have unemployment. So our data contains 3 variables and of 100 observations. So we'll start right away by coming up with a 5-number summary for these key columns: GDP per capita and unemployment rate. So let me execute this. We realize that the data set, there's no missing values or missing data. 100 observations, and we have average GDP per capita 10,574.13, and that unemployment is 3.84, and you have their respective standard deviation, minimum value and maximum value. And now what follows is that, and first of all, let us remind ourselves that this command simply gave us the number of observation, minimum value, average, standard deviation, and the maximum value of each of the variables that were used in this summary statement. We can populate a frequent table of region based on GDP per capita. You have to, in the region you have rural and urban. So let me execute this, and you realize that rural and urban statistics have been generated, and realize that rural has less average GDP average compared to the urban counterparts. We can do some visualization, like coming up with the histogram of example of GDP per capita for urban guys, and it will take some time to plot. This is the representation of GDP of the residents who stay in urban areas. And now let us look at the rural areas, how it appears. We realize that most rural areas and the GDP falls below 12,000 USDs, but the urban counterparts, we realize that the GDP was higher than 25,000, span up to more than 25,000 USDs. And we can as well have a two-way scatter plot of both unemployment and GDP per capita. And now we just need this color to be orange, the color of those dots, and the line of best fit, I will make it to be blue. And what follows, just to add the titles and some axis labels. So plotting this is what we get. We realize that we will get a negative trend. GDP increases with reduction in unemployment rate, and unemployment increases with a reduction in GDP. It's time now to answer our question that is about our research question that says that is GDP per capita significantly associated with unemployment rate. So another hypothesis will say that GDP per capita is not significantly associated with unemployment rate. On the other hand, alternative will say that GDP per capita is significantly associated with unemployment rate. Now to do so, we need to do a simple regression analysis that is done using this line of code. And upon running this, the higher GDP per capita, the less the unemployment, or simply the GDP per capita is expected to reduce the unemployment rate. The model is statistical significant. It's negatively correlated, which means as unemployment rate increases, GDP reduces, and as GDP increases, unemployment rate reduces, and it is statistical significant. And we are moving now to the next case study, which is case 2 about healthcare data analysis. And before that, we need to clear our memory so we can allow new data set. And this is the data set we are going to use, healthcare data, and it's an Excel file. So let me just execute this, and let us now browse this data and we check how it looks like. So we have this data around it. The data contains 5 variables. I have age, gender, hypertension, BMI, as well as smoker, and 5 variables of 150 observations. And the research question is that are age, BMI, and smoking status predictors of hypertension? Now we realize that hypertension will be our dependent variable, and now we have a rough idea that hypertension is a binary variable, and whereas with binary variables, the only model that is applicable here will be a logistic regression. It will be logistic regression. Now we realize that we will have to use logistic regression, and this we can do some descriptive statistics like summarizing age and BMI, which means you just need 5 number summary. You can also generate a frequent table for both gender and as well as smoke or smoking status and whether someone has hypertension or not. So I just run this all together and we check it together at once. So I executed that at once, and let us start with BMI and age. BMI and age, this is the table. So we realize that the dataset contains 150 observations, and the average age 48, standard deviation 18, the youngest guy is 18 years, and oldest guy or old guy is 80. And BMI, we realize that the average is 25, standard deviation of 3.96, minimum 13.84, and maximum 35.24. So basically, yes, there's unusual in this because normally BMI ranges between 18 to 25. Realize that this one maybe will be flagged as an outlier, but let us see and check. And on gender, we realize that male and female are equally distributed in this data set. And on smoking status, whether a person is a smoker or not, we realize that non-smokers represent a higher percentage of 74%. Whether someone has hypertension or not, we realize that majority of the respondents do not have hypertension, 78% of them, and 22% of them have hypertension. Establishment of BMI versus hypertension, we need just mean and standard deviation of those guys. Those guys without hypertension have a BMI of 25, and those guys with hypertension have a BMI of 24. And now the guys with the hypertension have a higher standard deviation than those of without hypertension. This is the summary we get, that individuals without hypertension, where hypertension equal to 0, have a mean BMI of 25.48 and a standard deviation of 3.74, and the individuals with hypertension, where has hypertension is equal to 1, have a lower mean BMI of 24.30 and a higher SD or standard deviation of 4.62. And the overall mean of the BMI for the total sample is 25.22. Here, 25.22. This is the overall. And the overall SD is here, 3.96. We can do some visualization. Like let us create like a box plot of BMI based on hypertension. We realize that our box plot has one outlying data point, and this data point, the one that I first flagged it here. Let me just let us browse the data. It is this one. So we can change it. So we can modify this data by editing that. So we can edit this. Maybe let us try and fix it like something like 24, which was close to average. Yes, I want to change. And now let us rerun our plot. We have fixed that, and realize that this is the representation of guys with hypertension, and without hypertension based on BMI. So generally, the guys without hypertension have higher BMI than those with. We need to do our model, and we need to remind ourselves for research question which was saying that our age, BMI, and smoking status predicts of hypertension. And we have another hypothesis to say that age, BMI, and smoking status are not predictors of hypertension. And on the other hand, HA simply says that at least the age, BMI, and smoking status are predictors of hypertension. And logistic regression will be our friend here. Just need to use logit, or you can use probit as well. Logit has hypertension, age, BMI, and smoker. So running this model, this is what we get. So just look at this model briefly. Let us age is statistical significant, BMI no, smoker no, and generally the model is statistical significant, but predictor or prediction power is very poor. So what can we say now after seeing that? So we realize that age, as you saw, was statistically significant. In fact, it was positive predictor of hypertension, which means that as age increases, the likelihood of having hypertension also increases. And BMI is not a statistical predictor of hypertension, although it shows a slight negative trend. And smoking status, on the other hand, is also not statistically significant, suggesting no clear association in this model. And now let us try and create a marginal probability to see how each variable will be affected when we increase each by 1 unit. So this one, we get this. So when we increase age by 1 unit, we realize that we are increasing the probability of someone having hypertension by 0.6% or 0.6% unit. And when we increase BMI by 1 unit, we reduce the chances of getting hypertension by 1.6%. 0.2% unit, and the same to smoke by positive of 1 or positive of 2.1 units. Let us see our documentation here. In fact, the marginal probability is simply a dy dx, or just a differentiation. So it simply means that, for example, for age we got 0.006, so we multiply by 100, we will get 0.66. And now in a nutshell, you say that each additional year or a unit increase of year will increase the probability of having hypertension by 0.66% units, holding other variables constant. And on the other hand, BMI with the dy dx of this and p-value of this, it means that each unit increase in BMI is associated with a 1.1 percentage point decrease in probability of getting hypertension. But this effect is not statistically significant, as we saw. Only age has a significant impact on the likelihood of having hypertension. And now let us try and see now the marginal probability plot, how each of the predictor is associated in this model. Now you realize that if someone is a smoker, the likelihood of getting being hypertension is very high than any other, then age, and then finally BMI. And now let us finalize with the case study 3, which entails survey data analytics, and we will clear our memory again, and we load data, survey data, and let us browse. So you realize that you have respondent ID, satisfaction score, income level, and education status. So the research question is that, does income level influence satisfaction score? So let us again review the data. Does income level influence satisfaction score? So income level, you realize that it is categorical data, and it has three groups. The most likely model we are going to use is ANOVA analysis. ANOVA analysis. We will use one way. In fact, it is one way ANOVA analysis. So before we proceed, let us have some descriptive statistics. This is the result of income levels. We realize that we have high, low, and middle. So majority of guys are from the low group, followed by middle, and the lowest at high. Do summary statistics, or 5-number summary of satisfaction versus year of education. This is what we get about satisfaction and years of education, or years someone took to study. Minimum 6, maximum was 19. And satisfaction, minimum satisfaction, which means dissatisfied, is 2, and highly satisfied is 5. Across tabulation. So this is the satisfaction score. So you realize that the happiest guys are from the middle group, followed by the high group, and then finally the low group. Maybe you can visualize the same using a bar graph. So still now, this is a visualization now. Yes, middle guys are are most happy than the rest of the groups. The least group that is so we can say that the group that is sad is the one in the lower income scale. We need now to encode our data since the income level is in character format, so we need to encode them to be as factored format. So we encode first, and then we run our model, and this is the result. So though the model is funny, but I guess we needed you to understand what's happening. So the income is not statistically significant to satisfaction score, which means that your income level does not it's not associated with your level of satisfaction, and generally the model is not significant. So guys, this is the end, and thank you for being here. Please support us by subscribing and sharing our content, and as well as liking. Thank you.